All right, today we're looking at 11.2. This is areas of trapezoids, rhombi, and kites. And really all that we're going to need for today is surprisingly 2 formulas, not 3, because the formula for rhombi and kites is actually going to be exactly the same. So the area of a trapezoid is equal to 1/2 the height times base 1 plus base 2. So if we have our trapezoid, does not have to be an isosceles trapezoid, can be any trapezoid. The height is just going to be from any point straight down. And the bases are the parallel sides again, right? So we have base 1, base 2. And if it kind of helps you, this kind of fits together the same way that we were talking about yesterday. If we took this exact trapezoid and we kind of rotated it, ooh, that's fun, rotated it around, right, and it fit back into this side, so you'd rotate it and flip it, you would get this large parallelogram, because this side would be parallel to the side that's now over here, right? And then you would have base 2 happening up here, right? So you have base 2, it would come down something like this. You'd have base 1 down here, and so you have base 1 plus base 2 times the height, and then these 2 trapezoids are congruent, but we only have half of it for the one that we actually want, giving us 1/2 the height times base 1 plus base 2, going back to our area for a parallelogram. And again, the other is for area of a rhombus or a kite. So it's the same formula for both of these. This is 1/2 diameter 1 times diameter 2. So if we had a rhombus, something like this, we have a diameter here, so this might be, the length of that might be d1, and our length here from here to here would be our diameter 2. Or if we had a kite, notice that when I draw my kite and rhombus, I'm using the properties that we have to be able to kind of make it without having to do a lot of work with the lengths on the sides. A kite, right, these 2 parts have to be congruent, and then the diagonals are perpendicular. Diagonals are perpendicular, and all of these are not congruent to each other, but these are congruent. They're bisecting each other. Again, you'd have like diameter 1, and not a diameter, it's a diagonal. If I said a diameter on the other ones, ignore it. Know that I meant diagonal because that's what we're talking about. This is not a circle. All right, so we're going to jump into some examples real quick here to take a look at how these work. So if we need to define area, which is all that we're going to do today, let's say we started with here like this, and it is a trapezoid. We're given that the height here is 16, the upper base is 32, and the lower base is 18. So all we have to do is fill it in. We have area is 1/2 the height times base 1 plus base 2. The height here is 16, right? So we have 1/2 of 16 times 32 plus 18, or 18 plus 32. 1/2 of 16 is 8 times 50, that is 400. This was all in feet, and our area is feet squared. All right, if we looked at another trapezoid, uh, 24 yards, 12 yards, and 28 yards. And what you want to notice is that even though it's pulled off to the side here, because it is perpendicular, right, that is our height. And then we have our two bases. Again, area is 1/2 the height, 28, times base 1, 12 plus 24. That's 14 times 36, which is 504 yards squared. All right, so for the most part, it is just plugging in the numbers actually to find our answers there. All right, how about a kite or a rhombus, depending on which one we have here. So, well, it doesn't matter for the problem because both will find the same way. You should recognize what it is. So this would be a kite. Oops, 20 and 20. That's these two parts here, which are always congruent in the kite. And this part is going to be 26. And this part is 56. Okay. And the area here is 1/2 the product of the diameters. Did it again. The diagonals. The D stands for diagonal. All right, so 1/2 the product of the diagonals. And that means you do have to add to find them. One of our diagonals is 20 plus 20. And the other diagonal is 56 plus 26. That's 70 and 12, which is 82. And if we multiply those together, we get 1,640 inches squared. All right, this one might be marked up like this, giving us the length here as 20 centimeters. This one as 10 centimeters. Okay. And this is a rhombus by the definition of what we have going on here. Our area is 1/2 diagonal 1 times diagonal 2. And so we don't just go off of what it, We don't just go off of these two numbers, right? The diagonal is all of this. This is saying that from here to here is 10. So you need to know that this is also 10 and that this is 20. So we get 1/2 of 40. It's the sum of these two times 20. And we get 400 centimeters squared. All right, we're going to look at just one more example. It is a little bit tougher, but it applies all the same way. You just have to know what we're putting in. So 164 is going to be our area. And we may be given a figure like this that you are going to pretend is a nice looking trapezoid, which it is not. Right, and we're going to be given the rest of this information here, where the part that we actually don't know is not the area we know, but we don't know the height, right? That's what we're going to look for here. So we do everything the same. We are still, this is a trapezoid, so we have the area equals 1/2 the height times base 1 plus base 2. The area is 164, so we put that in for the area. It's 1/2 the height. The height is x, we don't know what it is, times base 1 plus base 2, which is 32.8. Now you have some choices. You could multiply both sides by 2 to get rid of the 1/2 and then divide by 32.8. You could do 1/2 of 32.8 and then divide that 16.4 from both sides. Probably the best two options you have. I'm going to say that I would probably just, because 32.8 is so easily multiplied by 1/2, I would probably just do it. Divide both sides by 16.4, and we get x is 10. I think I said that was the last one. We're going to look at one more that's like that. What if we had the area is 247.5. That's going to be in millimeters squared. And say we're given this kite, 22.5. And we need to find this other side, which is x millimeters. Right. So again, area 1/2 diagonal 1 times diagonal 2. That is the area 247.5. 247.5. 247.5 is equal to 1/2 of 22.5 times x. And you can do it again either way, multiply both sides by 2, divide by 22.5. I probably would still just divide by, or multiply by the 1/2. I get 11.25x. And then using a calculator, dividing both sides by 11.25, and x is 22. All right. From there, you can find the homework on the Canvas page. If you have any questions, let me know. Again, mostly it's just dealing with those two formulas. These last two just put, you're looking for a different part of the formula and filling it in.